What I'm going to tell you is the aspect of materials, bio-based materials, Techno Cycle, biocycle, and lots of inspiration. And I would like to inspire you with lots of information. So my name is Els Zijlstra. I'm the founder and creative director of a material district. I used to be an architect, and in architecture there's a lot going on regarding this topic, and I'm glad to hear that it's also in the boat industry. We have an exhibition about innovative materials in Hall 10 in the first floor, and I'm going to show you lots of information. So the yachting industry is progressing, new techniques, new energy, new materials, in the Techno Cycle, but also in the biocycle. This is a fantastic yacht of Frank Gehry, the Foggy, totally made of CLT, cross timber laminate, laminate timber, and with lots of glass in it. So are we able to make new yachts of bio-based materials or totally recycled materials, yes or no? So what I'm going to talk about are these 4 topics. First of all, the transitions. We are now in the middle of climate change, but there's not only the climate change, CO2 is not the only problem, it's also about raw materials and our health. So there are 3 transitions going on. CO2, so the climate, energy discussion, the raw materials, and health discussion. I'm going to tell you something about the ladder of circularity, the Techno Cycle, the biocycle, and lots of information and inspiration about materials. Transition. This shows how we have changed from bio-based materials into mineral materials like concrete. So in time we have used concrete instead of natural materials. Aluminum has displaced wood. Metals become dominant. Plastics, of course, is the youngest material source. Replace natural fibers. And it's a problem because all these materials will not be eaten by microorganisms. They are not natural recyclable. This is also a diagram of our book Booming Bamboo. We wrote this together with Pablo van der Lucht. He is a specialist on bamboo and bio-based materials. And here we can see on top of the horizontal line, we will see the annual global production of the materials like the fossil fuel, so the fossil materials, stony materials, metals, plastics, and naturals. Under the horizontal line, we'll see the global reserves. So how many of these materials do we have left to use? Fossil fuels, we use them a lot. Oil, gas, oil, we do not have enough. We have only 200 years if we use oil and gas in the same amount as we do now, including the 200,000 people a day, which will be added on the world population. Stony materials, there's still enough, but it's depletable, it's not renewable. Metals is not enough for the next 200, 300 years. Plastics, as long as they are connected with the oil and the petroleum-based source, they are not enough. We cannot use over and over again these plastics. And of course, the bio-based materials are always available because they grow while you're using them. And the other thing is, of course, one of the members of the panel also mentioned it. It's also about the toxic emissions during production or during recycling the materials. So these 3 transitions is what we are working with. So the energy transition, the raw material transition, and the health transition, and they are integrated. You cannot look at them in a different way. So the ladder of circularity, actually, this is a very handy way to look while you're designing or how you are looking at the process. We all know the biocycle and the Techno Cycle scheme here from the foundation which is explained, but it does mean from the top down, first of all, try to refuse new materials. Try to maintenance, try to repair it, try to find a new purpose if you do not use the material in its original source. Try to reuse it, try to refurbish it. And if you really, really have no other source, try to upcycle the material. And so here you can see the difference of the abiotic and the biotic, so the bio-based cycle and the Techno Cycle. Try to prevent that it will come over there. Try to prevent that it will be in landfill or burned, because if you burn it, it's gone. And then you are just wasting all this energy and material. So if we go and look at the Techno Cycle, this of course is the problem. I really like the comment of this gentleman before. He said, okay, the last boat is of the poorest owner, and he does not have money to recycle it or to bring it to the wharf. So this is an interesting topic. So you have to, well, the discussion about it was very clear. And of course, if you do not do that with all the plastic, single-use plastic or whatever plastic, which is not decompostable, we have to clean it up. So this is the 2 projects of the ocean cleanup. Of course, the system 10B, which is cleaning the sea. And a few months ago, Boy and Slot of the ocean cleanup also introduced the interceptor, because you have to start, of course, with the rivers. 1,000 rivers on the world are going to be cleaned by the interceptor to prevent that it will come into the sea. So this is just one huge cleanup action. We have to make sure that it will not come so far. Windesheim is also trying to recycle these GRPs, and they shredded it. And then they made a new composite of it, so you are able to recycle or reuse thermoset plastics. The interesting thing is in the architecture, in the building world, and I think that it could be interesting for the yacht world also, is that this transition and the recycle industry is means a lot of new business. So a lot of new companies say, okay, we have to make a passport of buildings. We have to make material passports of the things that we design and what we make. We need to inventorize what is a product and what is a building, and we have to write it down. So if you demolish it, you can share it. You can put it on some kind of an eBay, like Harvest Map is. This is some kind of a marketplace or eBay, but especially for used materials. So if you are a designer or architect and you're looking for something, you can go to this marketplace to use these materials. So the logistic process of demolishing the materials, store them, and to find a new purpose of it, this is a total new business, and there's money involved in this new business. So it's not waste. The value of waste will become higher again. The problem of the techno cycles, the mineral cycles, the concrete, the plastics, metals, is that it's not possible to reuse everything and then we have enough. So in the Netherlands we have the grondstoffenakkoord. This is actually about the raw materials. That we say, okay, in 2050 we are not allowed to take anything new out of the earth. So no new bauxite for aluminum, no more natural stone, no more new virgin materials. We have to deal with the materials that we are using here. We have to recycle it, etc., etc. So 2050, that's the goal in the Netherlands. But if we look at aluminum and steel, of course you can recycle it, but it's not enough to meet demand now and in the future. So it's not that you say, okay, we will use all this aluminum. So you need to use virgin aluminum unless you go and look at bio-based materials. Concrete is the same. You can recycle it, but you still need new virgin materials. It's a carbon-intensive virgin cement. It needs always to be added. There's a lot going on about new kind of cement, bio-cement. Very interesting because the concrete industry knows that they are on top of the list of the most polluting, CO2 polluting industry. But still, it's a lot of problem. And plastic, of course, is the most difficult one. There's lots of sorts of plastic, costs a lot to recycle them. It's much more profitable to burn it because then you gain the energy of it. And this is what we never hear, the toxic emission by the production of plastic and also by recycling it. So plastic is actually a very difficult material and should be avoided if you can replace it by some other material. The biocycle is much more interesting, and there's a lot going on there, because material-wise it's a very, very interesting solution for the problems we are dealing with now. And the only problem is, of course, if you try to make a boat of wood, you know, of course, it's not fire resistant, it's not strong enough, it's not resistant against moisture and fungus, etc. But you can engineer it. And the engineering techniques for bio-based materials in a sustainable way, so not adding all kinds of chemicals or heavy metals or other shit, is really, really becoming very, very good. So if we are able to increase these materials, the quality of these materials, we can replace plastics and minerals by these new kind of materials. So that's the wood, of course. All kind of wood can be increased on some very complicated way. But other bio-based materials like cork or paper or bark is also really, really very interesting. So cork, since we are using screws for our wine bottles or plastic corks, we have a lot of, Portugal has a lot cork left over and is trying to find new uses for it. If you put, cork is fantastic because you do not have to cut tree for it, you just harvest every 7 years the cork layer of the cork oak. And all Portugal is filled with these cork oaks. It's fire resistant, it's antibacterial, it's very lightweight, it floats. Of course, you use it already on the decks. If you put it in some kind of pressure tank and heat and pressure add to it, then it will behave like popcorn, so it will become twice its volume. So very good acoustic insulator and vibration insulator. So cork, just watch the possibilities, of course. Also for interior use, a lot of interesting lightweight fire-resistant materials can be used. We, of course, I'm always looking at all kind of industries. So whether it's for fashion or in the sport industry or architecture or interior, shop around, go to other industry fairs because you find the most interesting materials. Everybody is busy now with this sustainability topic, and the packaging industry is the one who is investing the most regarding this topic. So try to find what they are doing. Interior and the sports industry too, defense industry too, regarding lightweight, because there the interest is the highest in the sports and the military industry. So there's a lot going on over there. Bamboo, it's called in Asia the poor man's timber because it's a rather cheap material. But again, if you engineer it, you are able to increase the quality. You can make it strong. You can make total facades and window frames of it. You can make terraces of it. You can. It is very, very sustainable, very durable, hard material. You can bend it. You can make boats with bamboo. It's some kind of cross-laminated bamboo panel. Again, if you try to engineer it in the right way. Paper is not a very common material to think about, but the packaging industry has lots of paper sorts, form paper, honeycomb paper, all kind of strong paper, absorbing paper, or just water repellent paper. This is a rather old project, but it's the Fury, and it's totally made out of cardboard. It has trespassed the canal between Rotterdam and England, and of course there has been, it has totally been coated by, I think it's some kind of polyurethane coating to make it water resistant. But if you look at bio-based resins and bio-based coatings, there's a lot going on regarding that. In the future, perhaps we are able to make cardboard boats with a bio-based resin on top of it. What's also really interesting is the development of biotechnology. So the use of mycelium, algae, yeast. And mycelium is actually a fungus, and the spores are growing very fast, and you can add all kind of waste from wood waste or dust or a little scrap to it. And then it will, so these are the spores, and they connect actually the waste that you add to it. So you are able to make insulation, very lightweight insulation. It has been developed to replace the styrofoam packaging materials. But now it has been developed into materials like boards, like here, some kind of MDF panel. They are making building blocks with it, building panels with it. You can even make a boat with it. You can 3D print with it. Here, this is really fascinating. So it looks very ugly, but it does not smell or whatever. It's just the algae or the bacteria are stopped. So it's not that it's growing out of your building or your boat. But this is a really interesting material. And the same thing with all those biofabricated materials are algae, yeast, and seaweed. So this is a whole technology where everybody is looking, how can we make new materials with this very carbon-absorbing material, very fast-growing materials. So this is actually the material for the future in fashion and in sports and in interior and architecture and all kind of industry, the food industry too. So watch these materials. And of course it's the algae and seaweeds are also coming from the sea, so it's really interesting for you. Another big topic is everybody's looking at waste. Everybody is looking in their bin. Okay, what kind of industry has leftovers, has B choices? What can you do with the garbage? Try to use all the materials during your production process and reuse it. So, for instance, well, very literally, if you have wooden closets or wooden scrap, you can make new panels or new floor panels or new furniture of it. The other one is paper, by the way. Nutshells, fantastic material. All the nuts that we eat here, all the shells are left in Asia, and they are burned. It's a waste. You can grind them, then you can make powder of it. You can add a resin to it, if possible, a bioresin, and you have fantastic composites. There are a lot of examples, also in the architecture, water-resistant facade panels made totally of 100% bio-based walnut shells or peanut shells or in this way macadamia nut shells. Think of all the shells, think of all the nuts, and you can use it. Coffee, really interesting. There is a lot of coffee. We, Dutch, drink the most coffee of all the European. We drink 50 kilo coffee a year per person. That's a lot. And what's coffee? The only thing that we do is extracting taste, because it comes from Colombia or wherever, and we burn it or roast it, and then it's transported and packed, and the only thing that we do is extracting the taste. So if we have 50 kilo a person a year, think about the amount of material source of the coffee ground that's left. So a few years ago, one designer thought, oh, I'm going to gather all this. I'm going to Starbucks and I want all this old coffee. Of course, logistically, that's a very big issue, but if you do it on the right way, you have a continuous stream of material sources, same quality, and then you have a structural waste stream. Most of the designers or startups think, okay, I'm going to use this and this and this waste, but it's really fascinating to see if it's a structural material, how potential new material it can be. Since this guy started, I think 10 years ago, a lot of industry has copied it, and there are now a few, I think 6, 7 coffee composites. Of course, you have to add something to it, but it's a really interesting way to look at the materials. Vegan leathers, also really popular because the meat industry has to diminish. It's of course a big CO2 problem. So vegan leather, the one above is made of mycelium. It's the same fungus I talked before. On the right you can see fruit leather. It's made of leftover fruit from the markets. It started there from some students in Rotterdam. They started to have all the fruit and the vegetables, and they cooked it and they made some fruit leather. And it was very popular, but it was eaten by mice and bacteria, etc. So they improved it, and they tanned it, and they reinforced it. And they also thought, okay, we are not going to the market anymore. We are going to upscale it. And they found out that 20,000 mangoes each week are thrown away in the Netherlands because we do not like the black dot on the cover. It does not look nice, so we throw it away. So we have our very spoiled Western generation, but it's spoiled, so you can make new materials of this. Food industry, huge waste industry, but if we do not want to eat it, we can make new materials of it. And there are a lot of other examples also made from the stem cell of the yeast, and then it's grown into a new kind of leather. It's all this biotechnology. It's really fascinating. This is Orineo. This is some kind of poured floor, which we use now epoxy for, or polyurethane or whatever. And he uses for the binder for the fibers also cork and also coffee. And he is able to use bio-based resin. So he's really interested in developing bio-based resins with a high quality for interior use, made by linseed oil or resin by castor oil or other bio-based sources. Interesting thing is, what we heard from the panel before, is that some bio-based plastics look the same like petroleum-based plastics. That can be a plus, but it can also be a minus, because if you buy bio-based plastics, you want to see this investment, because it's always much expensive. So if you do not see the bio-based source or the sustainable source of it, why should you pay for a plastic which is more expensive but just look the same like any other petroleum-based? So the branding of those new materials is also a really interesting topic. Bioplastics in general, so what kind of material sources can we use to make new plastics? And of course, it does not mean that it is all biodegradable, what's told before, because biodegradability and compostability is something totally different. But here you tackle the problem of the material source. As you saw before, petroleum-based, not good, is toxic, it's not renewable, it will end. And bio-based sources are good. So cheese has a lot of protein. Process of the production of it leaves wheat. You can use the protein of the wheat. You have new plastic. Made from CO2 and agricultural waste, can make new plastic. Mastic, how great is that? That you make new plastic out of cow shit. Actually, that's it. Make plastic from old shit. Nuattan is also a new material, new plastic. It's made by of PLC and PHB, and it's actually coming from starch, from potato starch or corn starch. It's also a huge new source. And again, of course, the discussion of bio-based sources, it should come from waste. We are not going to use food. If it can be used for food, you are not going to make a material of it, because food is higher, it's a higher hierarchy than material. So try to find the leftovers in the agriculture industry and in the wood industry to make new materials. Like blood. Sounds very icky, but you can make plastic from blood. I don't know what happens with all the blood from all those slaughtered animals, but you can make plastic instead of sausage. Liquid wood, cellulose. Cellulose is, of course, one of the most available, abundant material in the world. The animal version is chitin. Chitin is into the shrimp shells and crab shells and lobster shells. And in the vegetable variety is cellulose. And you can use this and make new kind of plastic with it. You can it behaves like normal plastic, and you can make fantastic stuff. So on the right there's a facade. It can also be for outer use. Algae, foam made from the algae. And this is just the top of the iceberg. We have lots and lots of these kind of materials. So regarding the exhibition that you can find in Hall 10 into the entrance to the Ecelium, we have an exhibition, and we have collected from our collection lots of materials. I'm going to show you some. Aluminum foam with salt. Perhaps you know aluminum salt, like when it's made as a powder with a foam component, and you have some kind of bread or made of aluminum. But here you can see the forms of the salt, which is solved in water, but then you have a lightweight aluminum. This is more a designy thing. There are lots of materials. If it wears out, we do not like it anymore, while the performance is actually the same. So lots of new generations are making materials that will become more beautiful or different in time. So if it's with a wear surface or scratch surface, it's not that you say, okay, I'm going to throw it away, but there's added some more aesthetics to it. This is a composite made of the shells of oysters, oysterplot. This is a very high-end material. It's perforated by hand, so it's a veneer with it's perforated by hand in any kind of form you want. But it's wood. This is a textile made of wood, so it's a totally wooden textile. You can make fashion. You can can be flexible. Can make interior cladding. Really interesting material. Translucent leather. It has had been tanned by the Dutch tanning company Eco Leather, done by Icelandic designer Schuli Recht. And you are able to make leather translucent. It looks very much like plastic, but it's totally leather. And it's the same thing like the bones that you give to your dog. You know this, so that's actually also leather, and you can give this also to your dog. It's like food, so it's totally sustainable. The recycling of plastic, it's really interesting. I've done a workshop with the ocean cleanup company. Okay, they are going to find all this plastic. What are we going to do with this? And one of the main things, first of all, it's really very difficult because it's very toxic, very terrible shit what's coming out of the ocean. Very fine granulates. It has to be closed in closed containers because the toxic emission is huge. But okay, let's find new ways and products which you can make of this plastic. And then there's some interesting thing that you see because it's the branding. Whether I make new plastic coming out of the canals here in Amsterdam or I use the ocean cleanup plastic, there is some kind of different in the branding. So and it all looks the same, but you can make it differently. So lots of designers are busy now from how can I make recycled plastic with an own DNA, with an own identity. It's all about the identity of the material, and how can it. And how do you call it? Is it recycled plastic, or is it new marble, or is it? How do you call it? And how can I recognize that this is a recycled plastic? So this branding identity discussion is also an interesting one. The yachting industry uses a lot of veneer for all very expensive wood, but you can also use it from banana leaves. So this is great, and also bamboo veneer. You can just skip all the hardwood materials because there are fantastic materials from vegetables. There is ananas fiber, leather. This fantastic banana fiber. This is peat. This is an acoustic panel which is made from 85% of peat, 50% of recycled bottles, plastic bottles. It's their own new kind of aesthetic, but you recognize the bio-based component of it. It's always a little bit round. You can see the fibers, so the feeling of it is very good. This is a metal which is CNC milled. So this picture is totally CNC milled aluminum. So you can have all the pictures or photos you want. And aluminum is a great material because you can recycle and recycle it over and over again without losing the quality. And that's not many materials have that. So plastic does not have it, paper does not have it. It's all a down cycle story, and aluminum, you can recycle it over and over again, just like glass. This is a material that's made from linoleum leftovers, and this designer tried to make a total new material with the same components of as linoleum, and also makes it translucent. This is an experiment where copper copper powder has been put on a resin layer with graphene in it, and then it's electrified, and then the copper behaves like a very natural structure. So this is a very aesthetic story. It's just for interior use, but it's interesting to see what happens here. And how about dyes? Well, how about pigments? What do you think what kind of toxic stuff there's in all those coatings and all those dyes in your clothes and in textiles and in materials? So this, of course, you can use bio-based pigments. They fade very quickly. And this company has recycled the dye. So they extracted the dye, the pigments, out of old textiles and reuse it again. So it has the same quality. Plasticide, well, this is just one of the hundreds of examples of recycled plastic panels. And you can see, okay, this is how it looks like. It's a little bit of a, okay, it's recycled. But how the development of it is huge. Another thing, what I just mentioned before, go to other fairs. Go and look what other industries are doing. For instance, the Techno Textile fair in Frankfurt. It's a totally different fair. It's about technical textile for filtration industry, for conveyor belt industry, for, you don't know what you see for the agriculture industry, but you can see the most fantastic materials for your industry too. And this is a project where this filtration materials, very cheap, very normal, ordinary stuff that's made in kilometers every day. This has been used by a designer to make furniture of it. So, and if this company is interested in adding a new kind of industry, then it's of course really interesting. This is some kind of CLTs, like cross-laminated timber, but then in small for interior use. So it's very strong and interesting. And this is my last example, and of course again the bamboo, you can make bamboo in all kind of versions. You can burn it, you can use a variety of bamboo sorts with its own aesthetic, and try to use these materials which are really crafted in Asia and really beautiful too. So these are just some examples which I would like to share with you. If you want to see more, go to the website, materialdistrict.com. And we publish new materials every day. It's for free, accessible. You can write or you can subscribe and you get the newsletter to it. And we have also our yearly fair here in the Netherlands, but we have this exhibition in Hall 10. So I would like to say, okay, go over there and be inspired. If you have any questions regarding your own project, just come to me and I try to help you with this. Thank you. Any questions also now which you would like to share? No? Yes.
Thank you. I would just like to ask how far, because there's always a problem with when you like to transform industries. So you have distributors and for example, with the wood, the fabric that is made out of wood material. So do you know how far the process already is? Because now at the moment we rely on, I don't know, cotton or poly or
you mean the upgrading quality of wood?
So yeah, and how far it is how easy it is to replace the current, like the trade chains and all steps that are necessary to kind of transform an industry to insert a new material in it. Do you know how far that process is?
Regarding the wood
Yeah.
in this, yeah. Well, there are some. It started with in the architectural industry where platen just to cook the wood, but one of the most interesting ones is Accoya, and Accoya is if you look at wood as a natural source, what's the problem? Why does it rot? Why do microorganisms like wood so much in combination with water? And it's in the CO2, it's the hydrophil part, so it's a chemical part. If you replace this hydrophil into an acetyl by putting it into an acid and under pressure, so all the hydrophil will be replaced by acetyl, and then you're just talking about acid, so it's not all kind of toxic stuff, then the microorganisms do not like it anymore, and they don't eat it anymore. So all you need is a big tank, a pressure tank. You need this special acid where all the wood is going to. And everything with cellulose is possible to improve in this way. So it can also be done by bamboo. It's a bit tricky because it's not permeable, but it's another story. But you can also do it with MDF. So MDF or all kind of composite wood, everything with cellulose can be improved like that. And you get the same quality as the hardest hardwood. So you can make just normal local pine wood, you can upgrade it into hardwood with just using acid. Actually, I don't know, the pickles, the augurken, which we eat here, the acid, which is in the potje, the jar of pickles, comes from this industry. So this is one of the examples of improving this material. Does that answer the question? No.
It was rather about how likely it is, because I think cotton and other things, they have maybe some disadvantages which wood could solve, and how likely it is that wood will replace those materials in the future.
Yeah, well, okay, that's of course depending, first of all, of price. Everything is about price. And that's a bit of the problem. The bioplastics, for instance, are mostly still more expensive than petroleum-based plastics. In 2013, everybody said, oh yeah, bioplastic is going to be the future, and then the oil price dropped. So all the petroleum-based plastic became cheaper. And price is always leading. But sooner or later, we do not have this petroleum-based oil, and sooner or later, bioplastics will become better. So first of all, it's price and the availability and also the market. Second, it's of course the governmental rules. We heard this in the discussion before. If the government is putting rules like, okay, this is the amount of toxic emission that you can have, this is how, like we have in this raw-based agreement, in 2050 you cannot use mineral materials anymore. Everybody is now looking at recycled materials or bio-based materials, because this market, this rule, will prevail, will come sooner or later. And a second, or the third, so first is price, second it's the governmental rule, and third it's the society. And we are responsible for what we are doing. It's not government, it's not price, but we, of course, can take a responsibility by not using single-use plastic, by everything that you buy is bio-based or is environmentally friendly, etc. And the more people are doing that, and the more conscious people are about the problem, well, the better the solution, and the faster this transition will come. And it's complicated, like every transition, but it's and of course the new generations are really very aware of the problem. They are totally into it. So it is also a matter of time that this perception will change. So yeah, okay.
Sorry, this
Hello.
is slightly off the wall, but you were mentioning the plastics, and you were mentioning how much pollution is created to create them. We're talking about Mets being more sustainable, but I keep seeing plastic everywhere, plastic water bottles, plastic in the canteens for orange juices and things. does Holland have a special recycling for this kind of plastic? Because to my knowledge, what we're using for cups is not recyclable, and the bio-based plastics are not recyclable unless you have very specific conditions, which most places don't actually have.
Yeah. Well, it's in the Netherlands we always think that we are very sustainable, but we are not, first of all. And there are also lots of lists. I think Germany is more sustainable than we are, especially with the packaging. In Germany they are very aware of the packaging. It's a totally different packaging environment that we have. But again, it's about awareness and about knowledge. So. And it's so complicated, you know. If you just what you say, bio-based plastic does not mean it's compostable. Plastics are so complex, and it's so strange to think. And it's also it's the best material there is. It's durable until hundreds of years. It can do everything you want, and it's so cheap. So and that's why we use it. I have another lecture about faking, about imitation. And that's also a fantastic topic to think about, because in architecture, but you also hear all those fake teak decks with plastic, and it looks like with a rubber band in it. Okay, it's all made of plastic, because, and also the flooring and terraces and wood is being replaced by plastic, because we do not want to clean it or maintain it anymore. We are too lazy, or we do not understand that you have to maintain natural materials. So we replace it by plastic, and now we have the problem. So, and everything, and metal and natural stone and woods and biobased, even cork, is imitated by plastic, grass, plastic grass. We imitate it because you do not have to maintain it anymore, but then you have the problem. So how is it possible that plastic, which is such a durable and multi-performable material, is so cheap? And why is it? Because there's another discussion too. It's all about price. We pay the price of the pollution of plastic now. So there's also a lot of discussion. Why do you not put the price, have a variable price, that everything that it's costing in energy and in waste and in toxic and pollution, etc., that's the price of the product, and we have to deal with that. And again, it's about awareness and knowing how we have to deal with that. So it's we are in a kind of evolutionary stage. Okay, what are we doing here? So it's and it's complicated. Plastic and no material is imitating plastic. Plastic is imitating everything. And of course, yeah, it's fantastic stuff, you know. It can and it's, but you do not have to do anything about it. But it's for a price. We all know the plastic soup movies, and we all know so this recycle story is. That's why I always focus on bio-based, because that's always safe. Then you know, okay, you can just throw it away, and it's food for animals and microorganisms. But plastic is really very. If you do not have to use plastic, do not use it at all. So, anyone else? Otherwise, I wish you an inspiring day here in Amsterdam. Thank you.
Thank you so much. Thank you very much. Wherever, yeah. Thank you. Oh, thank you. Okay, good.